All right, hi everybody. This is question 132 from chapter 3. This question, we're given the formula for an oxide formed by an unknown metal. So the formula is M2O. We're asked to find the identity of the metal, and to help, we're given the mass percent of oxygen that's contained in the sample. Okay, so any questions of this sort you can calculate really easily by writing your percentage as grams and finding the difference from a 100 gram sample. I think that's the way that Dr. Shepard teaches it too. So 100 grams, and out of that, 16.99 grams is going to be oxygen. All right, so that leaves you with, well, actually, you know what? It doesn't matter yet. So this is going to be all oxygen. We're going to find the moles of that. We're going to use our stoichiometry here to get the moles of the metal, and then we'll come back with the mass of the metal for getting the formula weight. That's how we're going to identify this thing. All right, so moles of oxygen is 16.99 grams, and that's on about 16 grams per mole. Sorry, excuse me. And that gives us 1.061875. We could see in the formula weight here, we got 2 moles of the metal per 1 mole of the oxygen. So we're going to multiply this value by 2 and get the amount of moles of the metal. So moles of, here, let's go over here for this one. So moles of M equals, we can do it like this if you want. 61875 moles. I think he multiplies. I'm trying to remember how Dr. Shepard sets these up. I think it's moles of oxygen like that, and then you write your conversion factor as a division here. So you're going to cancel your moles of oxygen here, and you're going to end up multiplying your value by 2. That gives us 2.12375 moles of metal M. Okay, excellent. So we can get our formula weight now. All right, formula weight of M is going to be the mass of it over the moles. So the mass was whatever this is in oxygen. So 100 minus 16.99 for the mass. That's going to give you your grams divided by 2.12375 moles. All right, you get grams per mole. So exactly what you want for a formula weight. And this gave me 39.0865. And after that, you'd have to check table values for the formula weights of the metals and find whatever's closest to it. This is pretty near to potassium. So you can conclude pretty safely that your oxide is of this form here, and potassium's your missing element.